How are you doing today? We are in chapter 9. We talk about calculation and reporting results. Most of the time in the laboratory, you will obtain the results from the test, and then you will record those on a bench sheet, and then that bench sheet will then be put into the computer as your results that you obtained, and then you would report those to the EPA. If you turn over to page 174, we're talking about the idea of significant figures. It's grounded in the uncertainty of a measurement. So if you look at page 175, you'll see the meniscus is about 8.1, between 8.1 and 8.2. So in the book, they would say that 8.17 is a good estimate. Um, you could not go one further. You couldn't go 8.172 because the markings only allow for 8.1 or 8.2, and there's no way to know if you're 8.72. The tolerance is there, and then the analyst could not reproduce that on a normal basis. So when you're reporting data, you're only you report it. Let's say you use several instruments in your testing. You use a analytic balance, and then you would use maybe a pipette or a beaker. You can only report the data to the instrument that has the least accuracy and precision. So even though a scale may go 8.4728, you wouldn't report that to the EPA, your results. You would use whatever, like in this picture, you would use just 3 digits. So 8.2 after the period, 8.17, because that in your procedure, that instrument is the less of all the instruments that you use. So you use it down to the certainty that you can. Hope that makes sense. If it doesn't, you know, give me a shout on email or text. Um, so calculations, with the exception of dissolved oxygen meters and pH readings, the final results of most procedures that are performed in water and wastewater, and this is on page 178, is not directly determined from the actual measurement. So, like obviously, temperature and oxygen and pH, when you read it, it's going to give you a digital readout, and that's what you send to the EPA. So if it says 5.25 on the dissolved oxygen, that's what you write down. TDS, TSS, alkalinity, volatile solids, all those take some sort of calculation that you need to have. It's good that you know those for the test, for the EPA test, but it's also there are computer programs that can assist. So you can put in the different data set points, and it will shoot you out a correct number. On page 179, um, it says the analysis should always include a copy of the final results calculation used in the method on the bottom or the back of the bin sheet that documents the analysis. So if you're doing it by hand, I know some at the water plant that I used to work at, we did the calculation by hand, and it's not computer generated. You need to have that on the back of your bin sheet. If a calibration graph is used to generate a value, a location must be referenced on the bench sheet, or better yet, a copy can be attached to the bench sheet. Once again, just that we're sending in good results, and that the EPA knows that we're using the correct method and the correct procedure. Dry weight corrections. Dry weight corrections are used for the conversion of results obtained on a solid sample that contains water to a parameter results that would be attained if there is no water in the lab. We want to extract that water out, and we want to know how much that that solid is without the water. Performing the dry weight conversion requires knowledge of the water content in the sample, which means a total solids determination on the solids must be made in addition to the needed parameter test. Once the residual value is obtained from the total solids test, the percentage of solids can be determined. And so on the bottom there, you'll have several ways to that you can obtain the percent of solids out of a sample that you have. Page 180, reporting results. Most laboratory results, with the exception of pH and a few other parameters, are reported in parts per million units, either milligrams per liter or milligrams per kilogram, because 1,000 milligrams is equivalent to 0.1%. The custom is to avoid using parts per thousand as a reporting unit. Instead, of percentages are used. When we report stuff, most of the samples that we report to EPA are in milligrams per liter. Even smaller than that, we use parts per billion. So that's pretty universal. We are different than the metric system. America does a lot of things different, but in that in the scientific world, in the water wastewater, we still parts per billion or milligrams per liter is how we report things, which parts per million is the same thing as milligrams per liter. But normally in the EPA, that's how we report it, so that everybody's on the same page. I hope you enjoyed this short video just on reporting. If you have any questions, please give me a call.